Okay, so who's going to tell me what we had studied in the last class?
Ma'am,
Yes, yes, Andrew.
ma'am, 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 we studied median and altitude.
Yes, median altitude. We saw some properties of medians. Can you tell me what were that?
Ma'am,
Yes,
each triangle has three medians.
yes, and
All the medians meet at a single point.
all the medians meet at a single point. Okay, yes, and what is that point called? That single point at which all the medians are meeting.
Ma'am, centroid.
Central. Very good. Okay, and how many parts the three medians divide the triangle into?
Ma'am, six spots.
Six parts. Very good. So those were the properties that we saw about the medians of a triangle. And now we are going to see the properties of altitudes in a triangle. Let's make the triangle and its altitude first. This is triangle ABC. Okay, this is altitude A. Alright. Then let's also make altitudes from the vertices B and C. Okay. So now 90-degree angles will be forming where your altitudes are lying here, here, and alright. Now, an altitude of a triangle, like I explained yesterday, is basically a line segment which starts from the vertex and meets the opposite side at right angle. It starts from a vertex, for example, B vertex. Okay, what is the side opposite to B?
Ma'am, AC.
AC. AC? Yes. So now from the vertex, we'll start the altitude. It will go on AC, and on AC, it will make 90-degree angles. Okay. Now let's see the properties of the altitudes. Now, every triangle, just like three medians are there, three altitudes are there. Okay? In each triangle, every triangle has three altitudes, has altitudes, one from each vertex, one from each vertex. And if you look at this triangle, what are the altitudes in triangle ABC? ABC.
Excuse me, ma'am. I'm sorry I joined in late, but I missed what you said. Could you please tell me what you're teaching right now?
Yes, Amanda. Yesterday we left at the meaning of altitude, right? So today we are going to do properties of altitude. Okay, I just explained its meaning again. That is, an altitude is a line segment that starts from a vertex of a triangle and meets the opposite side. Starts from a vertex and meets the opposite side at right angle. Suppose it's B vertex. From B vertex I'm starting. It will meet AC, that is the line opposite to B, at and it will make right angles on AC. Okay, this is what an altitude is. Okay, and we started with the properties. The first one is that every triangle has three altitudes, one from each vertex. Okay, because three vertices are there, so from each one altitude will pass. Now, if we take a look at triangle ABC, what are its altitudes? ABC altitudes are AE. Okay, let's name them. Let's name this one B. Okay, and let's name this one F. So AE, BB, EB, and FC are the altitudes of triangle ABC. Okay, so what's the next property? That altitude is the shortest distance from the vertex to its opposite side. Shortest distance from the vertex to the opposite side is the altitude. Okay? From the vertex to its opposite side. Then also similarly, just like median, altitudes will also meet at one point. Okay, no matter what the shape of the triangle is. Okay, like this point they're meeting, let's name it O point. Okay, and the three altitudes always meet at a single point, no matter what the shape of the triangle is. Okay, three altitudes always meet at a single point, no matter what the shape of the triangle is. Okay. And then the point where three altitudes meet is in altitudes, if they're making altitudes and they're meeting at a point, that point is called the orthocenter of the triangle. Okay, it is known as the orthocenter of the triangle. Okay,
Ma'am, done, ma'am.
okay. So these are the properties of altitudes of a triangle. So,
Mm, Ma'am,
Yes, present. Have you guys written?
Yes.
Okay. Anaya, Abraham, total. Okay. Anaya, go.
Yes, ma'am.
Okay. Next, we are going to talk about what is the sum of all the angles of a triangle. What is the sum of all angles of a triangle? All angles of a triangle. Okay. Let's make a triangle.
And the sum of all the angles of a triangle is 180.
Yes, it is 180. Very good. Okay. But how is it 180? We will verify and see. Okay. That is perfectly right. Correct. But how is it 180? Okay. That is a C. So this is A, B, and three angles are there. This is one, two, three. Okay. So we are going to do the verification. What we are going to verify that sum of all angles of a triangle is 180. Okay, this we are going to verify. All right. Now, what we will do, we have a triangle ABC. Okay, and we have marked three angles in it. Let's number them also. Angle 1, angle 2, and 3. Okay. Now we will draw a line passing from A and parallel to BC. What's BC? This side. Okay, parallel to BC. Let's make that line. Passing through A and parallel to BC. Okay. Now let's mark it. Let's name this line PQ. This is P. Q. Okay. And angles will also be found here in this line also. Here one angle will form here also. Angle 4 and angle 5 will form. Okay, so in this diagram, 5 angles are formed. 1, 2, 3, 4, and 5. Okay, and what is the sum total of the angles that are forming on one line?
Hmm.
Ma'am?
Ma'am, all the angles, angle PQ and angle A will equal to 180.
Very good. P, Q, and A will be equal to 180 or
There are
1, 4, and 5.
alternative angles formed.
1. Yes, 1, 4, and 5 will be equal to 180.
Angle 5 and 3 is alternate. Angle 4 and 2 is alternate.
Very good. So, angle 2 will be equal to angle 4, alternate angles. Alternate angle. Angle 3 equals to angle 5. Okay. This is also alternate angles. Alternate angle. And 1 equals to 1. Why I am doing? Because this is common in both. Common in both. Okay. I'm using the green and to show you 2 and 4. This is 2, okay, this angle, and this is 4. This you can see that they are forming alternate angles. One is here and the other one is here. Okay. And then 3 and 5. 3, this one, and 5, this one again, alternate angle. And 1 is common in the triangle also. In 1, 2, 3, 1 is common, and 1, 4, 5 also 1 is common. Okay. So now with this, what we can conclude, if we add the two sides separately, okay, with what are the two sides exactly? What am I talking about? One is this part, okay, and the other is so. What am I talking about? One is this part, angle 1, 4, and 5. The other one is
Ma'am?
this 1, 2, and 3. Yes.
Ma'am, I know that 2 and 4 are alternate, then 3 and 5 are also alternate. And how come 1 is.
One is common in both of them. In 1, 4, and 5, one is there. In 1, 2, and 3, also one is there. So that is why one is common in both. Okay. So now adding them separately, how will we write it? Angle 1 plus angle 4 plus angle 5
Equals to 180.
equals, yes, angle
Angle
equals
1
to,
plus angle 2 plus angle 3.
yes, plus angle 3. Okay. So this is when this is the and when this part and this part is equal, and 1, 4, and 5, the sum is 180 degree. So the sum of the other side, that is 1, 2, and 3, will also be 180 degree. Okay. Now tell me, so with this we can conclude that so sum of the three angles of any triangle, the three angles of any triangle is 180 degree. Okay. Now, any doubt you guys are having, please ask me. Anything you want me to explain again? Any question?
I have a doubt, but it's not from this and it's not in math either.
You have a doubt, but it is?
It's from science, the science test.
Science test. then you can ask that in the science class. Okay, take for a bit. Yeah. Anyone else? Any doubt in this concept, this verification part? Hope it's clear. Anaya, hope it's clear. Please write this down.
Done,
Done,
ma'am.
ma'am.
Done. Okay. Abraham, Samuel, done. So in the coming classes, we are going to try on some questions on this concept only. Okay. Like you know the total is 180. When the measure of some angles, you know, you have to find the other one. How do we calculate that? Okay, so that we are going to do, and we will be doing some questions on calculating the measure of the angle inside the triangles. Okay,
Ma'am?
the sum of yes, sum of it all will be 180. Yes,
Okay,
Andrew.
so ma'am, most of the angles in most of the triangles will always be acute angles.
Most of it will be acute angles. Yes.
There are only some triangles with obtuse angles, very few.
Mhm. That is right. Okay. Written everyone.
Yes, ma'am.
Okay. Abraham written. Okay. So we will stop here. Okay. We will stop the math class here and we will, after 5 minutes break, we'll continue the science. Okay.
Okay, ma'am.
Okay, then see you
Bye,
on,
ma'am.
see you. Bye bye. See you tomorrow. 5 minutes break, you guys, and then we will go with the science class. Okay. Hope you guys are there. We are going to start with the science class.
Yes, ma'am.
Videos on, please. In the last class, we read about fluid friction and about pressure. Okay. So, anybody wants to tell what is fluid friction?
Can you repeat?
What is fluid friction or liquid friction?
An example of liquid friction is like if you put a submarine, like if I'm going underwater and I want to dive and I want to swim underwater, I want to move, I will be stopped. I won't go very fast as I go on land. It's because the liquid is causing a friction between my body.
Because the liquid is causing friction in your body. Okay, very good. Yes. So basically, what is liquid friction? It is a force that resists the force that resists motion within a liquid. Motion within a liquid. Liquid or through another medium moving through the liquid or through another medium another medium moving through the
Ma'am, this is chapter 15, right?
yes. So there are two types of frictions that can happen when it comes to fluid friction. Okay, there are two types of frictions that can happen: internal and external. Internal friction and external friction. What are internal frictions and external frictions? Any idea? Or if you want to answer, take a guess. Anyone? Suppose I'm having water. Okay. So internal friction is basically the interaction between the fluid's molecules. Okay. Water has molecules in it. Internal friction is the interaction between the molecules of the fluid itself. Okay. That is internal friction. Okay. But what is external friction? What is external friction? External friction is, suppose I am having water and the interaction of water or the water molecules is taking place with another body, with another body. Suppose I am having a boat. I am having a boat. Now, the interaction of water, okay, is taking place with another body, an outside body, can be a boat or a ship, or even a swimmer, person who is swimming, okay, even a swimmer. That is taking place when, like, it is another body, an outside body in the water, okay, or the liquid. That interaction is basically external friction. That is external friction. Okay. Internal friction is when the interaction of molecules is taking place in the liquid, okay, in itself only. External when some interaction of liquid is taking place with an external body. Okay. Hope this part is clear to you all.
Ma'am, could you please explain internal friction and external friction again?
Sure.
I didn't understand that
Suppose,
one.
okay, internal friction. Now, suppose I am having water. Okay. Um, Suppose this is the container, okay, and I am having water in it. All right. Now, water, we know that any liquid has molecules present in it. Okay, water or any liquid has molecules present in it. Now, these molecules are like the interaction of these molecules are taking place in the liquid because they move in the liquid. As we know, right? Molecules, they move in the liquid and it's their interaction with each other is taking place. This is internal friction. Okay, means the force and the resistance will take place in the liquid itself. Okay, but what is external friction? External friction, for example, I need a boat, okay, which is floating on the water, which is moving on the water. Okay, so boat is an external object, right? It is an external object which is coming in contact with the liquid or with the liquid molecules. This is an external object, external object coming in contact with, coming in contact with liquid, contact with liquid, causing resistance, causing resistance. Okay. So this is why, because it is an external object, because it is not a part of the water, like something from the outside. That is why this is external friction. Okay. More examples can be a big wooden box floating in the water, or a swimmer who is swimming in the water. That those are also examples of external friction. Okay. Those are also examples of external fluid friction, basically. Okay. Now, one more thing I want to explain to you all. Hope now it is clear to you. Now,
Yes, ma'am, thank you. I'm just copying this. Could you just wait a minute?
yes, yes, yes. Write this down.
Done, ma'am, thank you.
All right. Yes. Now, I'm taking the screen. Okay. Now, what is the direction of fluid friction as compared to motion? What is the direction of fluid friction in comparison to motion?
It
That's what I'm
always goes
going
down
to.
straight.
It goes down straight. It can go to the side also. Okay. But what's the main thing? That it is always opposite to your motion. Okay. The direction is always opposite to motion. Can you see this picture? Fluid friction. Can you see this? There is the blue part in this image is water or a liquid. Okay. The blue part in the image is a liquid. This is liquid. Okay. And this is your external object. This is external object. Okay. And where is the direction of motion? Means it is moving to this direction. It is moving to the right side. Okay. And but what direction is the fluid friction? Towards the left. Beneath the liquid, it's towards the left. So fluid friction, the direction of fluid friction is opposite to the direction of motion. Okay. When an object is there in water, the direction of motion is on one side, the direction of fluid friction will be from the other side. Okay, because resistance takes place now. All right, because resistance takes place, so there is opposite directions. They both work. The fluid friction and the motion. Okay, then one more image. Look at one more picture. This is a ship in water. Okay, this is a ship. Where is the direction? Direction is again to the right side, but fluid friction will work from on the left side, causing the resistance. Okay,
So the water
goes
is
on the
moving there, but the ship is moving to the right. I didn't understand that.
water, not exactly the friction. The friction force is applying on
Towards the
the
right.
towards the right side. Okay, yes. It's basically the friction force that is applying towards the right side, sorry, towards the left side, but the ship is moving towards the right side. All right, that is how friction is created, right? Yes. So now, yeah, what can you tell me? Like on in the last class, I explained about the factors affecting the friction. Can anybody tell me what can be the factors which affect friction? Anyone? It can be how much speed the thing is moving in the water, in the liquid. Okay, speed of the body. Then the nature of the fluid. It can be the nature of the fluid. Okay, um, and the shape of the body that is moving in the fluid. Okay, shape of the body that is moving in the fluid. these factors will affect friction. Okay? Why are ships and boats streamlined? Why are ships and boats streamlined? Why do they have that particular shape?
Ma'am, because without that streamlined body, you cannot be able to swim. Like fishes, for example, they have a streamlined body. Without the streamlined body, they couldn't be able to swim because the force they would not get, the force they would get would not be the right amount.
That is correct. That is valid. The shape of boats and ships are made in such a way that they can cut through the resistance and move forward. Okay, and they can through that resistance they can move forward. That is why they are shaped like that. Okay, nature of the fluid.
What does it mean by the nature of the fluid?
Nature of the fluid. It can mean simply how thick the liquid is. Okay, or it can be like um, the consistency, okay, the thickness of the liquid. It can be the molecules, okay. It can also be the depth of the liquid, all right, the depth of the liquid, all of that, okay, and the speed of the body, or what speed something is moving, all right. Then these are all factors which affect friction, okay. Then we also did pressure in the last class. We also did pressure in the last class, but I want to go through it with you all again. Pressure. So in the last class, we saw some examples of pressure, like a knife. Okay, when we apply pressure using a knife on the vegetable, it cuts through the vegetable very easily. It cuts it easily. Okay, when the area of it is sharp and we apply the pressure, it cuts easily. But if the area is blunt, of the knife is blunt, then we find it difficult to apply pressure and cut the vegetable. Okay, so basically, what is pressure? It is a force that is applied on the surface area of an object. Okay, a force that is applied on the surface area of an object, and basically it is applied perpendicular to the surface of an object. Okay, perpendicular. I explained you all what is perpendicular to the area of subject. Okay, suppose I have an object. This is an object. Its name is P. Okay, how will force be applied? Like this, perpendicular on. Okay, this is that. Means force. Okay, now the formula for pressure, therefore, F is force and A is the surface area. Okay, so pressure is equals to force upon area. Surface area. Okay, because the pressure exerted on the surface by the force is equal to the ratio of F to A. Okay, the pressure exerted on the surface by force on the surface by force is equal to the ratio of F to A. F to A. What is F? Force, and A is the surface area. Ratio of force to surface area. Okay. And force is always perpendicular, applied perpendicular to the surface area. Okay. Means that um, suppose green is my surface. This green is my surface area. This is my surface area. Okay. And red is my force. This is my force. Which is applied perpendicular on the surface area. Alright, so this is the formula for pressure. Alright, now what unit do we use to describe pressure? Okay, so SI unit of pressure, like I explained before, is Pascal. Is Pascal, which is also denoted as PA. Okay, alright, hope this part is clear.
Yes, ma'am.
Okay. If you want to write it down, I'll wait a bit. Just let me know.
Yeah, could you please just wait a little bit, ma'am?
Okay, sure. No problem.
Yes, ma'am. Done, ma'am. Thank you.
Okay. So you can also write the definition of Pascal. It can be defined as a force of 1 Newton defined as one Newton applied over a surface area of 1 meter square. A surface area of 1 meter square. Okay. Now we will talk about factors affecting pressure. Okay, factors that are affecting pressure, and pressure is dependent on the area over which the force is acting. Okay, like the surface area, the pressure highly depends on the surface area of something. Okay, and pressure we can increase or decrease it without any change in force. Okay, pressure can be increased or decreased. Pressure can be increased or decreased without any change in the force applied. in force. But how is that possible? Like if we are applying the constant or the same force over anything, how is it possible that the pressure is different? Force is same, but how can the pressure be different? Pressure can be different because of the surface area. Okay, pressure can be different because of the surface area. How? Suppose I have a brick that is placed on the ground like this. I have a brick that is placed like this. Okay, and the force it's exerting is equal to its weight on the object it's resting on. Okay, the force that it is exerting is equal to the weight um of it resting on resting on something. Okay, but if we place a brick like this, you know what happens? Then we have changed the pressure acting on the surface. Okay, we have changed the pressure that is acting on the surface. Okay, so basically, what I'm trying to say is, if the surface becomes smaller, the pressure becomes larger. Okay, in the first diagram, larger surface, lesser pressure. Okay, and in this one, smaller surface, higher pressure. Okay, so if the surface becomes small, the surface becomes small, the pressure becomes larger. The pressure becomes higher. Okay, now see, now try to understand this. Okay, again, I am explaining. Try to understand this. See, a brick is there. Okay, and a flat surface is there. And on that flat surface, I have just placed the brick. On that flat surface, I have just placed the brick. Okay, so more surface area. The whole face of the brick is placed on the flat ground. It is covering more surface area, right? It is covering more surface area because the whole part of the brick, the whole triangular part is placed on the ground like this. So it's covering more surface area. So the pressure applied on the ground will be lesser. Okay, the pressure applied on the ground will be lesser. But but see, now I have the brick. I have made it like standing. It's not lying flat. It is standing on the ground. The brick is standing on the ground. It is perpendicular to the ground basically. So now the brick will only rest in the only the small areas, small surface area it will have. Okay, that is touching the ground on the small surface area. Before the whole face of the brick was touching the ground, but now only one side of it, one small square side of it is touching the ground. So lesser surface area, but more pressure. This will increase the pressure on the of the brick on the floor. Okay, it will increase the pressure because surface area is small. Now, suppose I'm having a nail, okay, that we put in the wall, that we nail it in the wall, a nail, a small nail. Why does it have only a very small surface area? So that it can easily, so that while when we apply pressure, it can easily go into the wall, so that the pressure can be higher, so that the pressure can be higher. Have you ever nailed a nail in the wall with hammer? Have you ever nailed it? If you haven't, you can try it out. Okay, put the nail, place the nail on the wall, and put a hammer on it. Okay, if you hammer it, it will go in. After two, three times of hammering, it will go half in. Why? Hammering is the force applied. Okay, hammering is the force that is applied, and the nail that is going in because its surface area is very small. The pointed part of the nail is very small. Okay. So when the pressure, that is its surface area, the pointed part, so that when the force is applied, it has high pressure, it will go straight in. If you nail it 4 5 times with hammer, applying good force, it will go all in, okay, in the wall. So that is the concept of pressure. When there is a large surface area, there will be lesser pressure. Suppose if have you ever noticed that some nails are blunt when we hammer them, it is hard to even put them in the wall, to nail them in the wall. It is hard. Why? Because they do not have that pointed, sharp edge. Okay, that is small surface area. When they become blunt, their surface area increases, which makes it hard for us to hammer it in the wall. Okay, so large surface, lesser pressure, but smaller surface, when force is applied, higher pressure. This is the concept of pressure, okay, with reference to the force and surface area. All right. Hope it is clear. Any doubt? Clear? Okay. Simeon and Aya, any doubt?
No.
No, ma'am.
Okay. All right. So this is the concept of pressure. All right. And now, do you need some time to write it down?
Done, ma'am.
Then, okay, yes, Simeon. I just saw your question. In the book, it said plumule, which refers to birds and plants. And Willy is the actual term. So you wrote Willy. That is right, Simeon. You can use the word Willy. Okay. It's the,
So marks will not be reduced for that
no, no,
because the book is saying different.
no. It must be not be reduced. Okay? It's all right.
And in the last question, the human digestion one, I wrote
Mm-hmm.
I wrote a little extra about things
Mm-hmm.
that it was not written in the textbook. I got it from another textbook. So that is also
Okay.
fine.
That is fine. Yes, absolutely. That is fine. Okay. If you're writing extra, it's okay. No problem with that. If you're putting extra information, writing in your own words, okay, using some new words, all that is fine. Okay, but what is little not fine is that don't make the answers very short. Okay, please, like yours, I'm not talking about in general answers. You know? Okay, for everyone, that look at how many marks the question is, and then accordingly you answer. Okay,
I
yes,
sent mine today morning.
yeah, I saw. Abraham, you also please share your test paper too. Okay, science test paper.
Finished it.
You finished it.
Yes, ma'am.
Yeah, so please make a PDF and send in the group, okay?
Okay, ma'am.
And also the English assignment also, your English assignment too. Please share that also if you have, okay? In the group. Today I will check the science papers and I'll share the results with you guys today itself.
Okay.
Okay. And next
Yeah,
week,
ma'am, I had to tell you something. It was a 50 marks question paper yesterday, and you had given the time limit 1.5 hours, but I was able to finish in 2+ hours because I found the questions a little bit tough, ma'am. But in 50 marks question, could you please keep the time limit 2 hours because 1.5 hours was too short in 50 marks
okay.
question
All
paper.
right, no problem. No problem.
Even
We
I
can keep
found it long. I could only finish it three
Yeah,
and
ma'am. Even I found it long, ma'am. I ended up finishing it
okay.
at 7:30.
Yeah, ma'am, because 50 marks question paper is usually 2 hours, 2.5 hours you usually give.
All right. Mm-hmm. Okay, no problem. For a 50 marks paper, I will keep 2 hours. Okay, it's all right. Not an issue.
Thank you, ma'am.
Okay, so we are going to start with the next chapter of science from tomorrow. Okay, we'll begin with a new chapter, and I'll see you guys tomorrow then. Bye.
bye.
Bye, ma'am.
Bye, ma'am. Thank you, ma'am.
Okay, bye. See you.
Bye, ma'am.